And next one, I just didn't know the concept. It doesn't mean I will check source code. At least I didn't know the concept. Time-shared computer model. Likewise, we would have this, but this time it's time-shared computer model. We will have a single CPU, but we have n terminals. Well, in the past, we have a single terminal, right? This time, we have multiple terminals. As for the others, almost the same. No changes. Well, if I try to have a picture, this time I use a horizontal one. We have string 1, person 1. To string and person again. And here we have a single server and then output. Well, in the past, we have a single stream. So we have a person and then the server. So that's it. So after now, MN1, we have a single input stream. This time, we assume we should have multiple streams. Okay, multi-stream server, multiple stream system. Well, looks like this. So round robin, actually because of multiple streams, so we need to have a round robin manner. Round robin manner, so you will have this. All right, and let me click on this. All right, so say we tag 10 to be served. So this is a round robin manner. Well, multiple stream because we have 1, 2 to n terminal. All terminal can have its own generation of packets, for example. So we will have a multiple stream, but put them together so that we have a merge stream. If I want to have the individual one, actually it should be 1, 2 to n. So here we have the merge one. It doesn't mean we have a single string. No, this time we have a multiple string. However, we may have this case unfinished job. So we will have a feedback unfinished stream. Well, at this I emphasize single stream and current multiple streams. Once finished, then we will allow the next input from the terminal. All right, so problem statement like this. And this one actually should be a computer model with a CPU. And in CPU, try to accept n terminal. And if we want to know the behavior of the CPU, then how to have the simulation. Well, at this, look at this, multiple streams. Multiple streams. All right. So arrival, we may have arrival from terminal 1, terminal 2 to terminal n. And we will have n simulation run, same as ML1. And also, we may have n simulation up to now the same. But we don't let it have the feedback here. So if you want to care about feedback, actually feedback will be contained in the service of the CPU. Maybe not finished, so get back to the string and so that waiting for the next service. again, we will have some description for this model. This time, I skip them totally. And we will have the codes for this one. And we may have some description talking about the output. Well, you can check it and you can test it, and so that you will know everything's okay with the current description or not. Well, likewise, I gotta know the flow chart of the function arrive. Actually, function arrive, so we will have job arrival. And job arrival, then check CPU idle or busy. If CPU not idle, then if CPU is idle, so not idle, then we will involve start CPU run. Actually, allow the CPU to serve the current job, or otherwise it will be queue. So temporarily finish and return. So put it into the queue. So this one we will have for that. And start CPU run, that says we need to serve it. So we will remove from queue of the job. And also determine the CPU time. Okay. And actually, because it has been served, so we will decrease the job's remaining service time. So normally in served, of course, we will decrease, but if we know how long, then we will deduct the time. And actually, we will put it into CPU. So up now, yes, place job in CPU and schedule its arrival. Oh, sorry, its departure. Well, as for end simulation run, likewise, we may have the current flow chart. You can check it, and maybe it is somewhat small, so this time I skip the description. Actually, you can refer to the flow chart, and then you can know how it works. And also, you should feel the flow chart correct, so you can check it later if you have the task book. All right, of course, you should refer to this one, and so that you will have a time shell computer model.